How to simplify radicals. So there are several different ways to do this. So what I would suggest first is realize that a radical, square root, means what number times itself gives you that answer. So I think it's important that you have a list of those on your paper. The smallest perfect square is 1. The next perfect square is 4, and then 9, and then 16, and then 25, and then 36, and then 49, and then 64, 81, 100, 121, 144. That's probably enough. What do all these have in common? Well, each of these is multiplying a number by itself to get it. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. So in essence, if I were to take the square root of 25, what number times itself is 25? The answer is 5. Now you probably understand all that just perfectly fine. Let's take an example of one of the problems that you have up here, and I'll show you a couple different ways to do it. 147. So what I would do for this is I would take these perfect squares, have them written on my paper, and then I would try to figure out what's the biggest perfect square that goes into 147 evenly. So for example, 144 doesn't go into it evenly. That's ridiculous. 121 doesn't, 100 doesn't, 81 doesn't, 64 doesn't. 49 might. So I'm going to take a calculator. If you're not allowed using a calculator, then this method does not work very well. So I'll show you a different method as well. So if I take 147, will it divide by 49 evenly? Well, the answer is yes. So that means that I could rewrite this instead of the square root of 147. I could write it as 49 times 3. Now the key to this method is one of these numbers has to be a perfect square. What is the square root of 49? It's 7. What remains is the square root of 3, because 3 is not a perfect square. That's one way of doing it. It looks like you were trying to do it with a factor tree, factor shrub, if you will, but you erased it. I will show you that way to do this problem as well. But let's check out number 3, doing this same method. Then I'll go back and use the other method. So you're trying to find the geometric mean. So you got x squared equals 20 times 8. So x squared is going to be 160. So if you use the method I was just showing you, x is going to be the square root of 160. So which of these perfect squares goes into it evenly? We want to choose the biggest one. No, 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 yes. 16 goes into it evenly. Goes 10 times. The square root of 16 is 4. Square root of 10 is an irrational number. 10 has no factors that are perfect squares, so the answer is 4 square roots of 10. All right, well, let me show you a different way that requires more work, but may end up being easier for you. And this is using factor shrubs, factor bushes, factor trees, whatever you kids call it these days. So the idea is I want to break this 147 apart until I get all prime numbers. Prime numbers are numbers whose factors are only 1 in themselves. So 147, I know I can divide it by 3. How do I know that? If I add up these digits, 1 plus 4 is 5, 5 plus 7 is 12. If I can divide that sum by 3, it means I can divide the original number by 3. This goes 49 times, as we know from the first time that we did it. 3 is prime. 49 is not. It's a composite number. You can break that down to 7 and 7. Once you have all prime numbers, which we do now, you circle pairs of the same number. Why pairs? Because it's a square root. So a pair of 7s, for every pair you put one number on the outside. Anything uncircled stays on the inside. So you get 7 square roots of 3. Let me show you that same method over here for this problem. And if I was using that method for this problem, I would never actually multiply the 2 and the 18. You're just creating more work for yourself. So check how nice this is for a problem like this. So to get x by itself, I square root both sides, so I get this. Notice I'm not actually multiplying the 20 times the 8. It's just creating work for me. 20 as prime numbers, or it's getting closer to prime, is going to be 4 times 5. 8 breaks down to 4 times 2. 4 is not prime. It breaks down to 2 times 2. 5 is prime. 4 is not prime. Breaks down to 2 times 2. Bring down the 2. When I get to this point, just to make sure I've done it right, if I multiply these numbers together, I should get the same thing as I get when I multiply 2 times, or 20 times 8. So now, since it's a square root, I want pairs of the same number. A pair of 2s, a pair of 2s, no other pairs. For each pair, we put one number on the outside. I got 2 2s because I have 2 pairs. Anything uncircled stays on the inside. To finish this off, 2 times 2 is 4. 5 times 2 is 10. If you're doing geometric mean, which is what you're doing for this entire worksheet, don't actually multiply the things together unless you have to. You would have to if you had a variable in it. You would not have to if you don't. So hopefully that's helpful. If you have any specific questions, let your dad know, and then I can try to help.